Bismillahirrahmanirrahim. Greetings. This is going to be the seventh video lecture that I'm uploading about the concept of sequence and series. Now, let me give a short review about the lecture of the previous lectures, which is related to the topic of today's lecture. Now, we started initially with 1 plus 2 plus 3 and so on and so forth. We were given to add all of this up to 100,000. We knew that was not practical. It would take us days to do that. So we came up to the idea that can we somehow change the addition into multiplication, because multiplication is a repeated addition, and also multiplication simplifies addition. So we took a smaller sample from 1 to 10, let's say. 1 plus 2 plus 3 up to 10, including 10. And then we noticed that these numbers are symmetric with respect to the mid-center point between 5 and 6. As a matter of fact, if it is not an even number, 1 to 10 are even number, if it is odd number, let's say 1 plus 2 plus 3 up to 11, then the center will be a whole number. Now, we noticed that half of the numbers, 1, 2, 3, 4, 5, lands to the left of that midpoint center, and the other half lands to the right of that point. So that gave us the idea that if we think about the 1 plus 2 plus 3 as a kind of the pieces of a chain, they are welded together so that they are rigid, and then we rotate them so that the 10, the last one, lands under 1, which is the first, and then 9, 1 before the last, lands under the 2, and so on and so forth. By doing that, we did succeed to change the addition into multiplication, and we came up with the formula of n times n plus 1 over 2. That gives us the summation of that. Now, curiosity tells us that if we do know the sum of some terms of a series is equal to, let's say, n times n plus 1 over 2, which means we know the total summation, the total answer, can we find the terms of that series, or the terms of the corresponding sequence? You get it? So we have the series, we know what the outcome of that series is, the total outcome. We want to know, by knowing that, can we find individual terms of the word of that series. So that is going to be the topic of this lecture, and possibly 1 or 2 more to follow. So let's get started, shall we? Now let me zoom this one and stay out of your way. Now this is some elementary preparation. Now suppose that we are adding 1 plus 2 plus 3 plus 4 plus 5, all right? And this summation is a compact form of that. We can call it sigma notation. Now notice that if we subtract whatever this addition is from this 1 plus 2 plus 3 plus 4, if we subtract this or this, take this out of it, we will end up with this term, which is 5. You follow me? Take this out of this. In summation notation, now let me go down and see what I mean. Now, summation I equals 1 to 5 of this 1 plus 2 and 3 and up to 5 is 15. And summation plus 1 plus 2 plus 3 plus 4 is 10. And 15 minus 10, 15 less 10 is equal to 5. And 5 is what? One of the term of this series. No, we can do the very same thing with 4 and 3. So we can say we add 1 plus 2 plus 3 plus 4 and then subtract from that 1 plus 2 plus 3 and we end up with this 4, which is another term of this series. So that gives us the idea that can we generalize this one. Now what do you mean by generalize is that algebra is what is a generalization of arithmetic. So let's use algebra from this so that we can generalize the idea. So that will be the next one to talk about. So we have a series, the terms of that I equals 1 to n, a1 plus a2 plus a3 and so on, n number of them. And then if we subtract from that, as we demonstrated with numbers, a1 plus a2 plus a3 up to n minus 1, which is one term before that. All right? If we subtract that from that, we end up with what? We end up with the nth term of that word of that series. So we discovered what one of the term of that. I have put it in expanded form. a1 plus a2 plus a3 up to an minus less a1 plus a2 plus a3 and so on up to an minus 1. When we, very elementary grade school arithmetic, we subtract this from this, we end up with the nth term. So we found one of the terms of our series in that way. So we are trying what? We are trying to generalize idea. Now, then this gives us that, okay, now let's make an example of our own. Let's make an example of our own and see that if we know the outcome of a series, can we find the terms of that series? So I just came with, suppose that that series is that series equal to summation of ai equals to n square, right? Which means that if we add the terms of this sequence, of this series, if we add, for example, if this series has 7 terms and we don't know what they are, if we add them together, a1 plus a2 plus a3 and so on plus a7, we will get 7 square. You see that? This n is same as this n. So we get 7 square. So we want to know what will be the terms of this series in that regard. All right, now let me go to the next if I may. Okay, I'm repeating something again. Let me cover that one. Suppose we are given that one and we wish to determine each terms of this series. So we know the outcome, which is n squared. If n is 7, again I repeat myself, will be 7 squared. What are those numbers, 7 of them, that if we add them, we get 49, for instance. Now I have gone through this one, and let's see how we come to that one. Now, this is equal to n squared. Is that right? The outcome, the final outcome. And this is equal to n minus 1 squared. Is that right? Now, I wrote them very elementary, basic algebra. I wrote this one, n squared minus n minus 1 squared, which is the summation of this if n is, if the top of the sigma notation is n minus 1, and we end up to this fantastic formula. Now this formula tells us that for this particular series, you give me n, and I can tell you what are the terms of that word of that series. N is 1 is 1, N is 2 is 3, N is 3 is 5, N is 4 is what? Is 7, and so on and so forth. So this formula that we got from this algebraically tells us what are each terms of this series, that if we add them, we get n squared. Let's just try. For example, if n is 1, let's go 7 of them. N is 1 is 1, N is 2 is 3, N is 3 is 5, N is 4 is 7, N is 5 is 9, N is 6 is 11, N is 7 is 13. So if we add all these numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, we do get n squared, which is about 7 squared, which is 49. All right, try it. Try it for yourself. Now, we come and we want to see if we can generalize this idea. Now, we know that from this, we know that each terms of this given series can be determined by this. Now, I don't want that to be confused with the n, which is a number of the terms of the series. I put I so that it does not cause any kind of confusion. So we have a sub I equals to 2i minus 1. So you tell me what I is 1 is 1, I is 2 is 3, and so on. He gives us exactly the same thing here. All right. Now, when two things are equal, whatever we do to the left-hand side, if we do to the same to the right-hand side, the equality will be preserved. So A1, AI, we start to add them from I equals 1 to n. All right? So we made summation here. Summation I, this notation for the series. And then we use the same summation notation here. All right? And let's see what happens. Look at that one. So I add them all, I use the summation, do you follow me? And then I go ahead and I know what this one is, the outcome of that. What is the outcome of that is n squared. Is that right? And then I distribute them. 2 comes out of summation notation, so I get summation of I minus this, and lo and behold, look at that. Something I notice here, which is fantastic. I wasn't even aiming for that. It just popped up from thin air, and I'm so excited about that. So do you notice that? Right now, pause and look at this equation and see what do you notice. So I did a little bit mark that one for you to help to your eyes, and you notice that I have ended up with I equals 1 to ni, which I already know from previous lectures. This is equal to n times n plus 1 over 2. So looks like if I solve this equation with respect to this, if I solve it with respect to this, then I have found the formula for the summation of 1 plus 2 plus 3 plus 4 and so on and so forth, without going through the process that we did before, that we changed the addition into multiplication in order to end up with the formula. Fantastic, you see that? You notice that one? So let me now put this one, the last one for you up, if I may. So this is just very simple arithmetic I'm doing. I'm just rearranging the terms of this left and right side of the equality, and I end up with this. You see that this one is summation of I equals 1 to n. You are adding n numbers of 1. 1 plus 1 plus 1 plus 1. So in the end, in the long run, we end up with the n. So we know what that n comes from. and this is this one and this that. Now we solve it for this. We solve it for that. Look at that. Fantastic, look at that. It's just, I wrote also, lo and behold, is so excited, look at this. So I end up with sum of I equals 1 to n squared plus n over 2, which is same as n times n plus 1 over 2, which I wasn't really what, I wasn't really aiming for that. So I've written that one for example. So let me zoom this one back. Okay, then, it's very kind of exciting, is it not? I told you in the previous lecture that mathematics gives you wing, you see? You fly, always flying. And this kind of discovery, as a matter of fact, in the world of science, there are many discoveries has made by the scientists that they weren't even intending. It just popped up in the middle that they were not even looking for such a thing. So similar thing happened here for us. We started with this summation of I equals 1 to n, suppose that to be equal to n squared. So we were trying to reverse engineer and find the terms of that series, and we end up with the formula of n times n plus 1 over 2. Again, I repeat myself, we don't need anymore to go and do that, what? To go and change the addition into multiplication, as we did previously, to come up with the n times n plus 1 over 2. Okay, then, for the next 1 or 2 more lectures coming related to this, we are going to try some other one, like for example, with this n cubed, what will be the terms of that, or n to the 4, what will be the terms of them, etc. Okay, then I thank you all for watching, and as always, I wish you good health and prosperity, and please stay and remain safe. I always will end with the army salute and say, so long.